Kia ora, I'm Max, and I've been doing a summer research scholarship looking at the survival spores of Phythophthora agathidcida, which causes Kauri dieback disease. I've been based at Victoria University of Wellington with my supervisor, Dr. Monica Gerth. Kauri are a taonga or treasured species currently under threat from Kauri dieback disease. So there's no cure for Kauri dieback, and currently nearly all infected trees will die and end up looking a bit like this. So one of the big challenges of controlling Kauri dieback disease is a survival spore or ooze spore. These are found in the soil and get spread by people's boots and equipment. The challenge with ooze spores is they have these thick layers of cell walls, and that makes them incredibly resilient. So only bleach is truly effective at killing ooze spores, and more environmentally friendly disinfectant Sterigene that we use at the moment doesn't kill them very well when they're in the soil. That's a problem because that's where they're normally found. And so more effective treatments for ooze spores especially are desperately needed. So for my project I looked at pantothenic acid, this compound here, and some of its derivatives. So pantothenic acid has antimicrobial properties, which is what we're looking for, but poor diffusibility, so it doesn't penetrate into cells all that well. But that's quite important when you want to kill something like an ooze spore that has thick cell walls. And so one way of studying this property is to conjugate a fluorescent dye to the compounds you want to test. Stain something, such as some ooze spores, and then look at the intensity. And so the brighter ooze spore on the left will have had more compound penetrating into it, and hence it fluoresces more brightly. So a collaborator, Rudi Marques from the University of Canterbury, sent us a collection of pantothenic acid derivatives conjugated to the same fluorescent dye, and we wanted to test how well these could penetrate into ooze spores. And so the aim of my project was to observe whether any visible structures in ooze spores were stained by those compounds, quantify penetration into ooze spores using fluorescence microscopy, and also to assess which of the compounds had the best diffusibility. So pictured here is an ooze spore stained with one of the test compounds and at 1000 times magnification. And so something we can see here is that quite a lot of the compound seems to be getting stuck outside of the inner ooze spore wall and isn't penetrating past that. But you can still see pretty clearly that it's penetrating into the inner ooplast or cytoplasm, and that's where we need it to be if we want to kill the ooze spore, so that's promising. And this plot here is comparing the performance of the different pantothenic acid derivatives I tested. And on the y-axis is the mean ooze spore intensity. That's how brightly the ooze spores show up under the fluorescence microscope on average, and that tells you how much compound is penetrating into the ooze spore. And on the x-axis is the percent of ooze spores in the sample that was stained. And so the best compounds will stain a high percentage of ooze spores and at a high intensity, which will be the ones towards the top right there. And for reference, I've got regular pantothenic acid labeled towards the bottom middle. And so what we find is that the best compounds stained about twofold higher quantities than pantothenic acid did, which is really quite a big improvement, because in theory that could mean they're twice as effective at killing ooze spores. And these compounds are also staining a higher percentage of ooze spores than pantothenic acid, which is quite good because not only are ooze spores receiving a higher dose of these compounds, but they're reaching more ooze spores in the first place. So next steps here will be to actually test the biological effects of these compounds and see whether the improvements we've seen in these experiments hold true of their biological activity. And thank you to the Bioprotection Research Centre for funding the project, to my supervisor, Dr. Monica Gerth, to Professor Rudi Marques for providing the compounds I was testing, and to my lab group. Now, unfortunately, I'm not there in person to answer your questions, but if you are curious about anything, here's my email, so do feel free to get in touch if you want to. Thanks.